I'm going to show you how to find inverse functions. But before we do that, I want to look at some inverse operations. In my first expression, I have x squared. If I apply the square root to that, I would just have x as my final answer. These are considered to be inverse operations. A square root will undo applying the power of 2. In my second expression, I have x plus 3. The inverse of adding 3 would be to subtract 3. And in my third example, I have the cube root of x. If I raise that to the third power, I would get an answer of x. A cube root and cubing something are inverse operations. So now we're going to take a look at two functions. These two functions are inverses. And here's how an inverse works. I'm just going to choose the number 6. Let's assume that I put 6 into the f function. If I were to do that, 2 times 6 is 12, minus 8, I would get a value of 4. Now, if I apply the inverse to that, that means I'm going to take my number 4, put it into my g function for x. If I put that in there, 1/2 of 4 is 2, plus 4 equals 6. The idea of inverse functions, whatever you do to something should undo that, which means if I start with the number 6 and I apply its inverse to it, my answer should be the same thing that I started with. So these two functions are considered inverses. Here's another way of looking at it, and the order doesn't matter. Whatever I start with is what I should end up with if I apply the inverse function to it. So here's the steps I'm going to go through of finding inverse functions. In this last item, it looks like f raised to the negative first power. That's just a notation for an inverse operation. It does not mean we are literally raising it to the negative 1 power. So to find my inverse function, I'm going to go through those steps. The first step is replace the f of x with the letter y. Next, I'm going to switch where the x and the y are. My third step is to solve for that letter y. So in order to solve, I need to subtract 4. To get y by itself, I need to do the inverse of raising something to the second power. So I need to apply the square root, and I have to do that to both sides. Now, because I'm doing a square root, anytime we do a root of an even number, we can obtain a positive or negative value. So I do need to put a plus or minus in front of that. It could be either one. Now, if I were doing the cube root, the fifth root, I wouldn't need that. But because it's an even root, I need to put the plus or minus in front. So that means my inverse function, and this is just the notation, should equal plus or minus the square root of x minus 4. Okay, my next example, I'm going to go through the same steps again. I'm going to replace the f of x with y. Next, I'm going to switch where the letter x and the letter y are. Then I have to solve for the letter y. So in this example, I need to subtract 3 off first. Next, I would need to divide it by 4. And last, I'm going to have to apply the square root to both sides to get y by itself. And I need a plus or minus in front of that because it is an even number for a root. This one does simplify a little bit more. In the denominator I have square root of 4. I can just replace that with the whole number 2. Okay, once again I'm going to go through these steps. Okay, my next step would be I need to divide by 1/2. Dividing by a fraction is the same as multiplying by its reciprocal. The reciprocal of 1/2 is the number 2. So mathematically, I'm going to multiply 2 to the other side. So my inverse function would be 2x minus 3/2. My next example, I have a square root of x minus 8. In order to solve for y, the minus 8 is under the square root. I need to take care of the square root first, so I need to apply its inverse. So I'm going to square both sides to start with. These are inverse operations, which means the exponent of 2 and the square root undo each other. That's why I'm just left with y minus 8. Now I can add 8 to the other side, and I have my inverse function. This one's similar to the last, but I have a subtract 8 that's outside the square root. In order to solve for the y, I need to take care of that subtract 8 first. So my first step is going to be to add 8 to the left side. Next I need to apply the inverse of the square root, so I need to square both sides. Because I'm squaring both the x and the 8 together, I need to use grouping symbols. So make sure you have parentheses included. It changes the meaning if you don't have that. And last I would subtract by 3. So if you notice in my final inverse function, x plus 8, that quantity squared, then the subtract 3 is behind it. Here's 6 examples for you to try out. Go ahead and push pause when you're ready to start them. Then you can hit play again to see what the solutions are.